Okay, so last section for this week is first half of section 8.1, and it's on what we call the law of sines. So the whole goal in section 8.1 and 8.2 is I'm going to give you a triangle, and I want you to tell me how big the sides are and how big the angles are. That's it. We've done this before. When we did Sokotoa. Now, when we did it before with Sokotoa, every single triangle always had a 90-degree angle in it. We're going to do the same thing again, except now the triangles are not going to have a 90. Okay. Triangles that don't have 90-degree angles are called oblique triangles. There's really two different types of oblique triangles. We're not going to be drawing things to scale, so it doesn't really matter. But you can have a triangle where every angle is less than 90. Think of like an equilateral triangle. They're all 60. Or you can have a triangle where one angle is bigger than 90. That's an obtuse triangle. Why can't you have a triangle with two angles bigger than 90? Right, they got to add up to 180. So you can only have one angle bigger than 180. So when we're solving triangles, we use certain labels for the sides and for the angles. What are the three things we normally use to label the sides? Well, that's what I'm going to ask for next, what you started to say. We always use A, B, and C for the sides. And then for the angles, we use Greek letters. Yeah, well, we're definitely going to use alpha and beta. A, B, and C, that just comes from what we've done before. Alpha, we always put across from A. Beta is always opposite B. Now, the angle opposite C, we never gave a name to it before, because it was always the right angle. So since it was a right angle, we didn't need to name it. Now it's not a right angle, and we're going to label it with that Greek letter. That's gamma. G-A-M-M-A. Gamma. Like gamma rays. Now, you don't have to use those labels. You could use X, Y, and Z for the sides. You could use PQR. It doesn't really matter. But if you use those labels, it just kind of helps things to keep track of things. So I would stick with those labels. So when you're solving a triangle, there's 6 things to find. Okay, there's 3 sides, there's 3 angles. Well, I can't just give you a blank triangle and say solve it. I have to give you some information. In fact, I have to give you half the information. So out of the 3 sides and the 3 angles, that's 6 things, I'll give you 3 of them. One way I could give you information is I could tell you 2 of the angles and 1 of the sides and say find everything else. Now, if I give you 2 angles and a side, there's 2 ways I can do it. And by ways I can do it, it just means where the angles are that I give you. I can give you 2 angles and a side like this. Say I gave you angle, angle, side. So in this case, you've got 2 angles. And you have the side that's between them. It's the side that's between the 2 angles. Okay? So if you did proofs in geometry, you might have used these abbreviations when you do proofs. We're not really using them to do proofs. We're just using them to describe the 3 things we know. The other way I can give you 2 angles and a side is like this. Let's say angle, angle, side. The difference there is you've got 2 angles, but the side that you know is not the one between the 2 angles. It's on the other, it's a different side. This is the side that's between the 2 angles over here. It's the one that connects them. Okay? If you know the one that connects the angles, that's this type. If you know the side that doesn't connect them, it's that type. either way, you're using the law of sines for both of these types. And the third type, the last type that you use law of sines for, is when you have side-side angle. That would look like this. Side, side, angle. So in this case, you know two of the sides, and you know one of the angles. But the angle that you know is not the one where the two sides meet. If it was the one where the two sides meet, it would be side angle side, and that would be right up here. You couldn't solve that, not with the law of sines. Okay. Yeah?
Could that also be interpreted as angle side side?
It could be.
Can you show some?
So you can write angle side angle backwards if you want, ASA. Doesn't really matter. You can write SSA backwards, SAA, AAS, same thing. We'll leave that one in that order. It's just nice. So if you're looking, there's two arrangements of letters that you don't see up here. Side, side, side is not listed up here. Side, angle, side is not listed. The reason they're not listed is because you can't do them with what I'm teaching you. You can do them with what's called the law of cosines. Okay. Today we're just doing law of sines. We'll look at those two some other time. So if you want to solve an angle side angle, a side angle angle, or side side angle, any of those three types, and only those three types, you use the law of sines. So the law of sines is basically three fractions. I'll show you the first fraction and see if you can guess what the second and third one are. So the first fraction is sine of alpha divided by A. And the second fraction is sine of beta divided by B. And how about the third fraction?
The sine of gamma divided by C.
The sine of gamma divided by C. That's the law of sines. Whenever you use the law of sines, you never use all three parts at the same time. When we're doing an actual problem, we're trying to find something, you're either going to use just the first two parts, just the last two parts, or the first part and the last part. But you only use two fractions at a time. And what you end up having is something like this. Does anybody remember what that's called when you have something like this? It's a proportion. So we're going to end up with proportions, and we cross multiply and solve for the leg. And that's it. Now, keep in mind, we already said this, but what do all the angles add up to in a triangle? 180. They all add up to 180. So you can still use that fact. But you can't use Pythagorean theorem. Why not? What kind of triangle do you have to use Pythagorean theorem? It's got to be a right triangle. Because in Pythagorean theorem, you have to have a hypotenuse. If you don't have a 90, you don't have a hypotenuse. Okay, so as far as the explanation for law of sines, that's it. So we'll do, I think I have 3 examples. If we get through them, we're good. If not, we'll finish up the examples tomorrow. All right, so the first thing I usually do is sketch that. Don't sketch it to scale. Just sketch it to see, is this one of the 3 types of problems that you should use law of sines for? Maybe it's not. And if it isn't, for now, you could just say, cannot be done with the law of sines, because you don't know the other law yet. But chances are, since I'm teaching you the law of sines, it's probably going to be one that you can use the law of sines for. So let's put A across from alpha. And again, this is not to scale. If it comes out to scale, great, but it's probably not. A across from alpha, B across from beta, and C across from gamma. So what kind of triangle is this one? Using like the 3 letters. A's and S's. Side, yep, you can say side, angle, angle, or angle, angle, side, it's either way. But if you look back in your notes, that is one of the 3 we should use law of sines for. All right, so now I usually set up a table. So let's put ABC in one column, alpha, beta, gamma in the other. All right, so we know alpha, we know beta, and we know A. We don't know B, we don't know C, we don't know gamma. Now, when you're looking at the table, if you have a row that's full, that's another way to tell that you use law of sines without making a picture. Our first row is full. So when you have a full row, that means it's law of sines. Okay. Yeah.
Is gamma 100?
Yes, gamma is 100. Yep. So that's probably the quickest one to find because all you have to do is add up all the angles, make sure they add up to 180. Now, when we did this with right triangles several weeks ago, what did I say about using something you found to find something else?
Never use it.
Don't do it, right? Good job. So, when you're dealing with right triangles, you can do that. When you're doing this kind of problem, you can't. There's no way to get C without using gamma. You can get B without using gamma. So if you made a mistake on gamma, you could still get B right. But if you make a mistake on gamma, you're going to get C wrong. Okay, so you have to use gamma. There's no way around it. So now we can find B or C. Doesn't matter which one we do first. Which one do you want to do first? B. All right. At least you didn't say neither. Could have been worse. So let's find B. To find B, you're going to pick a row that has everything in it, and then pick the row that has the thing in it you want to find. Here's the row with everything in it, so we're going to use that. Here's the row with the stuff we want to find. So let's go back and look up law of sines that has the A and the alpha part. Yeah, we don't need to look it up. So sine of alpha over A. That's the first fraction, except A is 4. So fill in what you know. And then on the other side, yeah, sine of beta over B. Again, just fill in what you know. Sine of 60 over B. And now solve for B. So how do you solve that? What do you have to do? Cross multiply. 4 times the sine of 60. And for now, you don't even have to worry about doing that out. You can just leave that. Equals B sine 20. So I've got B times the sine of 20, but I want to get B by itself. So how do I move sine 20? Divide. Yep. Divide by sine 20. That's gone. Divide by sine 20. And once we type that in, that's the answer for B. Any question on how we cross multiply there? All right, so now let's see what we get. First, make sure you're in degrees, which I am. 4 sine 60. Close parenthesis, divided by sine 20. If you don't close the parenthesis, we've had this come out before, but it would come out wrong. Okay. So we get 10.128. Let me try again. 10.128. Right. Right. Now when I find C, I have a little bit of a choice. I have two rows that have everything in them. Which row should I use? Yeah, how come?
It default products naturally.
Yeah, everything there was given, and the numbers are nicer, they're not rounded. So let's go back to row A again to find C. Now we'll find C. So it's going to start out the same way the last one did. Sine of 20 over 4. Equals. And what's going to go on the other side this time?
Sine of gamma over C.
Sine of gamma over C. Sine of 100 over C.
But did you say to never use 100?
What's that?
Did you say to never use 100 because it was not a given? Even though this one's a heavily...
Not for this type I didn't. No. I said you're going to have to. I said there's no way around it. You have to use the 100. So if you got it wrong, then C would also be wrong. But B would still be right. So. And now what do I do with that? Yep. And if you can do the cross multiply all in one step, that's fine. So when you cross multiply, you've got 4 sine 100. And then to get C by itself, you're going to have to divide by sine 20. If you want to write out the cross multiplying like I did here, that's fine too. But we're dividing by sine 20, just like I did up above. Now I'll take that in and see what we got. 4 sine 100. Do I have to close the parenthesis?
Yes.
Yep. If I don't, it's not good. Here it doesn't really matter because there's nothing else coming after it. So we get 11.518. Yeah, we'll just go with 3. Okay, what I usually do is just make sure the biggest side is with the biggest angle. Yep. Smallest side is with the smallest angle. Doesn't mean you got everything right, but if that doesn't happen, then something's definitely wrong. Okay. And that's a law of science problem. Any questions on that? On the test, this would count as 3 problems. 1, 2, 3. I grade all 3 separate. So there's like 10 of these on the test, but there's really only 3 because they have multiple. There's just many answers to each part. So there's 3 different triangles to solve on the test with multiple parts like that. Right, let's try this one. Okay, this time you don't need to make a diagram. You already have that. But what kind of triangle is this one? I mean in terms of the A's and S's.
Oh.
Remember, my sketch is not to scale at all. It's angle, sine, angle.
Oh, yeah, I see. It looks...
All right, so if you look back, angle, sine, angle, definitely one you use law of sines for. Okay, what did I do in the last problem to now organize all the stuff I have to find? Yep, make the chart, make a table. If you don't want to make a table, don't. It's up to you. But just kind of organizes everything. Now, they didn't label what 40 is, but based on where it's placed, you should know which one it is. What's the 40 here?
Beta.
Yes, 40 is beta. And what about 45? Alpha. And 4? C. It's across from gamma. Now to use the law of sines, I said you have to have a row with everything in it. Right now, do we have a row with everything in it? No. But can we find a row with everything in it? We can. And then we can use law of sines. So what would gamma be? Yeah? 95. Now, getting that angle right in this problem is very important. Why is it even more important that you got that angle right this time than the last problem?
Because we have to use that to find A.
You have to use that for everything. So you have to use the row with everything in it. So if you got gamma wrong, you're going to use it to find A and B, and then they're both wrong. So there's just no way around that with these kind of problems. Okay, so now which one we do first, A or B? Doesn't matter. A. What's going to go on the left side of my proportion?
Should we do sine of C or sine of
You can put, it doesn't matter. You can put the gamma and C on the right, or you can put them on the left. So you're going to do sine of gamma over C. So now, since the left-hand side has numbers for the top and the bottom, the variable is going to be on the right somewhere. Okay. What am I going to put on the right? Yep, and can you fill in the numbers for me? Yes. If you set up the law of sines and you have 2 letters in the proportion, something's wrong. You should only have 1 letter. Okay. And then, Isabel, what do I do from here?
Cross multiply.
Yep, cross multiply. Right, so can anybody tell me what you don't have to tell me like the decimal, just what times what divided by what? Yeah.
4 sine 45 over sine 95.
Yep. And now just type that in. So we got 4 sine 95 divided by sine, I'll fix that, 45. Okay, so 2.839. And that's A. Now, can I use Pythagorean theorem to get B? No. If I use Pythagorean theorem, I'm assuming I have a 90, and I don't. I have an angle that's close to 90. So if you use Pythagorean theorem, your answer will be close to being right, but it'll still be wrong. So we don't want to use Pythagorean theorem. Let's find B the same way we did A. Let's find B. Okay, so now I've got a choice. Top row or bottom row to use the row that has everything in it. Yep, go with the bottom because that was the one that was given. So sine 95, well, it wasn't given, but at least it doesn't have decimals. That's what I meant to say. Sine 95 over 4 equals, and what's going to go on the right side?
sine 40 over B.
Sine 40 over B. So now, when you solve for B, it's exactly the same thing, except change that number to 40 instead of 45. Right, so B is 4 sine 40 over sine 95. And if you're typing in a calculation and all you had to do was change one number, if you press second, enter, it'll just bring up the last thing you typed in. And then you can just change the one number. I don't know if that's faster, but you can do that if you want. Okay. So 2.581. Is the smallest side go with the smallest angle? Yep. How about the biggest side? Is it with the biggest angle? Okay. So that's always just a good thing to check and make sure nothing's obviously wrong. So any question on that? All right, so the last one, I'm just going to tell you about it. So the last one that we'll end up doing tomorrow is side-side angle. Out of all the types that we have, the ones we've done today so far, and even the ones you're going to learn with law of cosines, this is the one type you have to be careful of something. When you solve side-side angle, one of 3 things could happen. You either get one solution, which is like the problems we've been doing, so it just works out to be a normal problem. You get 2 solutions, which means it's not harder, but it's longer because you have to do everything twice. There's 2 answers for everything. Or the shortest case is when you have no solution. That means you start to solve it and you realize right away it doesn't work. You can't do it. All right. So tomorrow we'll look at the side, we're going to do this problem. We'll solve it and we'll see if it has 1 solution, 2 solution, or no solution. Okay, and that's the last one. So the lesson tomorrow will probably take about 15 minutes. All right, so the homework tonight. The 2 extra ones that I have on the board right here, 1 and 2, those are fine. You'll be able to do those.
Are those A's?
Yeah, those are alphas. Yeah, those are alphas. All right, number 5, let's see. Let me just look it up and make sure you can do it. All right, you know what? That should be mostly fine. 5 through 8, 10, and 16. There's one you get stuck on because we didn't finish the last case. We'll take a look at that tomorrow.